Hello, I'm Wesley Wharton,
And I'm Kyle Listerman.
and this is our AE100 video presentation, and today we're going to talk to you about our model rocket project.
This presentation is to show how different rocket designs cause different outcomes in the project, and the project taught us about different engineering design processes with rockets.
Our rocket was designed to have a smaller payload section that could still fit everything in it. This was to allow us to have a longer body tube section so that we would have more room to fit the parachute in, and it would allow for easier deployment and a successful parachute deployment so that our rocket would not crash to the ground. Our fin designs were trapezoidal in shape, and that was so that they would be simple but effective. So not too hard to design, but also very effective, and we chose 3 fins instead of 4 so as not to create too much drag so our rocket wouldn't become overly stable and so that it would still fly to a reasonably high altitude. The camera was mounted with tape inside the rocket facing outward so that it was a simple but effective way to capture the video of our rocket's flight.
The plot shows the thrust of the motor at all times. The peak is where the maximum thrust occurs between 7 and 8 seconds. When thrust drops to 0 is when the propellant runs out close to 9 seconds. The drop at 15 seconds shows where the ejection charge occurs, detaching the rocket body from the payload.
The trajectory of our rocket fits quite nicely with our expectations. The rocket's altitude increases very rapidly at first, up to around 200 to 300 feet, and that is when the motor is burning. Then the rocket coasts over to apogee, and when it achieves apogee, it initially falls until the parachute deploys at around 9 seconds. Then it coasts downwards with a constant velocity after the parachute has been deployed until it hits the ground. You're about to see a rocket flight done for this presentation.
This is, however, not our rocket flight because our camera was lost.
Alright, pad 5 in 5, 4, 3, 2, 1, ignition. Slow down range. Have a parachute. Come back to the field.
The maximum altitude of our rocket was 700 feet. We had an issue with our shock cord breaking, causing detachment. However, the parachute stayed with our payload, causing the egg to survive. It fit our expectation of an E96 motor.
Over the course of this project, we learned many different things, such as how altimeters worked, how to read and analyze different thrust and altitude curves, as well as how different aspects of rocket design affected aerodynamic performance, such as the different fin designs that we chose. We also learned about rocket stability and how you need to keep your center of pressure behind your center of gravity in order to have the rocket be stable. And then in our personal flight, we learned that you must protect the shock cord from the ejection charge, or else the shock cord will break and cause a detachment of the rocket. Overall, this was a really fun project, and we learned a lot from it.